This is an overview and explanation for doing the t-test. In class, we tested the reaction times, both without texting during the process and with texting during the process. We established the research question: how does texting compared to texting? How does texting compared to not texting affect the reaction time of Homo sapiens over 3 trials? Our null hypothesis is the act of texting compared to not texting will have no effect on the reaction time for Homo sapiens. And of course, we are going to try to reject that hypothesis, and we will use the t-test to help determine whether we can reject or fail to reject the hypotheses. Now, in your work for Monday, you will need to do several things. You will take the data that we generated in class, and again, using a spreadsheet, you will calculate the mean. You will calculate the standard deviation. You will calculate the standard error. And you will calculate the t-test. Those 4 calculations can be done using the spreadsheet. I'll come back and explain how to do the t-test on the spreadsheet in a moment. Following that, you will need to graph the means for texting versus non-texting, add error bars using the standard error, and then following the t-test, you will make a claim and back it up with evidence. Basically, by that, I mean claim whether you can reject or fail to reject your hypotheses and use the data and statistics to back up that claim. That should all be in your bill and ready to go on Monday before you come to class. So if we look at the t-test, when do you use a t-test? Certain types of data lend themselves to the t-test. It's when your x-axis or your independent variable is what we call a discrete data point. Discrete data, there's no range to it. So in this case, we have 2 categories. We have no texting and we have texting. There's not anything in between. It's either not texting or you're texting. Discrete categories. It's either black or it's white or it's red. There's no in-betweens. And your y-axis is what we call continuous, which means there is a range. In this case, we have reaction time. And it might range from 0 in this case to 2 seconds. I doubt anybody got as high as 2 seconds. It'll probably range somewhere between 0 and 2 seconds, but it could fall anywhere within that continuum. Thus, we call that continuous data. So we have a independent variable that is discrete and a dependent variable that is continuous. This is a good place to apply the t-test. Also, it's a good indicator of when to use a bar graph. Bars work well when you're dealing with discrete data. Now, there are 2 types of t-tests that we're going to deal with. One is called the paired t-test, and the other is called the unpaired t-test. These are pretty simple distinction. Paired t-test, both sets of data come from the same group. So in this particular investigation, our texting and our non-texting data both came from the same group of students. Whereas an unpaired t-test, the data for the 2 groups come from different groups. So if I had arranged this different and I had the texting data come from 2nd hour and the non-texting data come from 5th hour, that's 2 different test groups, 2 different groups of students, and that would be an unpaired t-test. We're going to be doing a paired t-test in this case. That's the one that we will most often use. And the t-test in general is one of the most commonly used tests in biology. This is the actual equation for the t-test. I'll show you several versions of it. The t-test is the mean of group 1, which in this case would be the non-texting, minus the mean of group 2, which in this case would be the texting. and that's absolute value, which means the value will always be positive, divided by the square root of the variance for group 1 divided by the sample size for group 1 plus the square root of the variance of group 2 with the sample size of group 2. That's one way you could calculate it. A little simpler form of it is if we take a look at this, s squared over n1 can actually be simplified because the square root of s squared, of course, would be s. So we're going from variance to standard deviation, and we still have the square root of n. And so if you take standard deviation divided by the square root of n, if you look at your formula sheet, that's actually the formula for the for the standard error of the mean. So I could rewrite the equation to be the mean of group 1, subtract the mean of group 2, absolute value, divided by the standard error of mean for group 1 plus the standard error of mean for group 2. So that's also going to equal your t-value. Either equation would be used, just depends on what you've got. If you've got your standard deviation value, you can turn it into a standard error measurement. If you've got just the variance, you can use the variance. But either way, this is the mathematical calculation that you'll be using to calculate the t-test. Now, in a computer format, which is what we're going to use in the spreadsheet here, it's got a couple more steps than the other programs we used. So the way to put this into an Excel sheet or Google Sheets is, again, you're going to start by typing in equals. Now with the t-test, you're going to compare group 1, column 1 with column 2. So you're only doing this once. You're not doing this twice. This is a test that's comparing both columns of data. So we're going to put equal t-test, parenthesis, and then you have to tell it first what two columns do you want to compare. So you've got to take the range. So say you've got, like in fifth hour, we had 44 data points. 42 data points. So we maybe the first data point was in cell A2, colon, and then tell me what the last cell is. And maybe that was, cell A44. So you have to tell me what's the first set of data. You can also do that by highlighting the first column of data. So my first data point for non-texting was A2. My last data point for non-texting is A44. Then you put a comma, leave a space. Tell me what the second group is. The second group, my texting group, started in cell B2, and that runs all the way to B44. So I'm defining what the two columns are that I want to compare. Then you have to put two additional numbers in here. The third number, you're going to put a comma, space. The third number is a 2. What you're telling them with the 2 is we have two tails. Right? Now, if you go back to standard deviation, remember it looks something like this. And there's our mean, and then we can fall within one standard deviation or two standard deviations of the mean. Out here are what we call the tails. That's where 2.5% is, and 2.5%, that's where we get our 5% from, recall. So you have two tails if your data was able to go up and your data was able to go down. In our case, your reaction time could have gone up, your reaction time could have gone down. There are two tails. So we put 2 to tell the program that we had two tails in our data sample. If you were only interested in one end of it, you would only have one tail. So for example, if I was testing a medication for blood pressure, I'm only interested in lowering the blood pressure. So I would put all of my data and effort into the one tail, not both tails. And that way you're putting the whole 5% over here versus splitting the 5% up. That makes that a much more tough test for that blood pressure medicine to pass. So if you only have one tail, you're only interested in either going up or you're only interested in going down, you'd put a 1, not a 2. In this case, our reaction time just as easily could have gone up as it could have gone down, so we have two tails. The final number we put in is a 1, and there's again a comma, space, and then a parentheses. And what the 1 means is it's a paired test. We have one source of data. Both columns of data come from one group. If this was an unpaired test, we'd put a 2, which means both columns come from separate groups of data. So that's what the formula looks like. So you've got your group 1 data. You've got your group 2 data. You've got your number of tails, which is going to be 1 or 2. And then you have the number of groups sampled, I guess you could say. So that's what you put into the cell for the computer. You can put that in the column. And again, you're doing that for only one of the columns, not both of the columns, because you're comparing the two. You're comparing the two. That's going to give you some type of number or value. You're going to get some type of t value. Right? That t value, then, like all other statistical tests, has to be compared to some type of table or chart. Has to be compared to some type of table or chart. Let me clean this off for half a second. So you can look this up online. Just go to Google and put in Ttest Chart, and all T charts are the same. You can look at any T chart, and then you read it like any other chart. You have to have a degrees of freedom and reference the chart. So degrees of freedom here is a little bit different. So degrees of freedom, you have to look at your sample size. So for example, in 5th hour, our non-texting had 42 data points. N was 42. So it's actually n minus 1 for the first group plus n minus 1 for the second group. So the first group was 42 data points minus 1, just like any other degrees of freedom. And in this case, our second data group was also 42. Doesn't always have to be the same. You might sometimes have a little bit more data on one group than the other. And so this would then be 41 plus 41, which means our degrees of freedom in this case would be 82. And that's what you would use then to find your 5% value on the T chart. All right. So find your 5% probability on the T chart, which again, you'll have to look up a T chart online. And like always, if your number is greater than the p-value, you fail to reject. If your number is less than the p-value, then you will reject the hypotheses and have evidence that texting did interfere with your reaction time. So I hope that makes sense. Good luck with the assignment this weekend. We'll see everybody in class on Monday. Go green, go white, go state.